Welcome to the community tutor TipVid for section 9, the various types of quantum technology. And I'm going to be talking about NV-centered, nitrogen vacancy centered technology, which is gaining a lot of approval in the sector. If we look at the traditional technologies, we've got the superconductivity, trapped ion, silicon-based topological, and these are the market leaders. But lately, well, in the past 3 or 4 years anyway, a new technology has been on the market that's very comparable, and that is NV-centered, particularly in diamond. So what does it actually mean? And what qualities does it have? Well, let me explain the qualities first, and then I'll go over exactly how the technology works. First of all, it operates at room temperature, which is obviously a big plus. It could also work efficiently over fiber optic because it is essentially optical in nature. And I'll explain that later. It's a small form, so already there are quantum computers coming out using NV-centered, and they're the size of a small suitcase, and they are very scalable. So it's all very exciting, but let me take you through how it actually works. Okay, so let us see how this actually works. Now, each carbon atom, diamond is made up of a lattice, which is the important part. It's got a lattice framework of carbon atoms, and each carbon atom is covalently bonded to 4 other carbon atoms. So you've got it like this, and then and so you get the idea. Now, in nature, in real life, what happens sometimes is, well, not happens all the time actually, is that you get defects within the structure. And quite often you'll get a nitrogen atom coming in. And so you've got nitrogen, and then next to it, you may have a vacancy. Okay, so you've got a nitrogen atom next to a vacant cell, and the two of these actually bond, and they act like one physical entity. It's called the NV center, and it actually has quantum spin. And so that is really interesting, because what actually happens is this NV centered here. So this NV center made up of one atom of nitrogen and a vacancy, what it actually does, it's like having 2 compass needles. And sometimes you can have both of them pointing up. Sometimes they can both be pointing down. And sometimes it can be one up and one down. And this is really great when it comes to quantum computing, because we can take this to be a 0 and this state to be a 1. And fortunately, we can now manipulate them to put them into state 1 or 0, and for us to be able to read them in state 1 and 0. Now, we're very fortunate because if we hit the NV center with some laser light, with green laser light, what happens is it actually glows red. So there's a red glow is emitted from the NV center. However, if the NV center is in spin up or down, it is a bigger glow, and it's a noticeably bigger glow that we can detect. So we can now distinguish between 1 and 0. And as soon as you do that, with a quantum spin, as soon as you do that, we have the ability to form a qubit. Thank you very much. I hope this has helped you, and I look forward to seeing you in the next section.